why they don't have these set to automatically update. I mean, when it does the update,
Yeah.
just go ahead and do it instead of,
Making you restart and do
I
it?
mean, it does the update, but it makes you restart it
Yeah.
instead of just doing it on its own.
Right. I kept thinking about if we had to use the Ford thing too, it's gonna... I need to go update that too. I talked to Stan yesterday, he said that part should be here in the week, well, next week, and then he said he was gonna bring it in, and then he asked me something about he had me so freaking confused, I don't know, but anyways, I told him, I said, well, you might want to talk to Ken about that, because I have no idea. He was talking about, I'm trying to think here. How did he say it was? I can't remember. Anyways, I'm like, that'd be something I would ask Ken. I go, I have no idea. So, anyways, next week he should be bringing it in with the part, so. Which I'd like to know how to change one of those, so that'd be kind of a good.
Oh, you'll get to learn how.
Okay, cool.
In theory, they're about as simple as anything. Thread the old one out, thread the new one in.
Yeah, I knew you said that. I was just, we were talking about them like breaking. So that's my concern.
His is so new, it probably won't be an issue, but yeah, on old stuff, quite often the threads will come out when I don't.
So yeah, that was what I was wondering about. And I still have yet to order my fuel injector control module, so that might not be for a few weeks. Probably get it about the end of class, I'm assuming. Or near the end anyway. So I was looking online on the one for AutoZone. They were saying for that fuel injector control module, you have to program it. And the one for O'Reilly's was like a plug and play one. You just plug it in and it works. So that kind of confused me
I would do some research.
because that just sounded like well,
I'm gonna say that if it's a programmable module,
I didn't think modules were programmable. I thought it was just the computer and the like PCMs and stuff.
It depends on what kind of module it is. So, yeah, very well could be. But when you buy it one place and buy it the other are both going to be the same, whether it's programmable or not, or whether it has to be programmed. I would assume it would be the same.
Yeah, that's what I thought too. So I was like,
That doesn't make sense, but
yeah.
maybe they're not. When I'm not correct.
Yeah, that's what I was kind of wondering.
Why I keep stopping right before the questions. That's good though. Maybe we'll see what you can remember from yesterday back to the question right off the bat. What happens when air fuel mixture is quenched?
So that was essentially where it cools it, right?
Mm-hmm. What
Becomes more,
happens to it when it cools down on those areas?
should be more efficient, but you need more details, right?
Actually, quenching's a bad thing.
My brain's not
What
working.
happens what happens to a liquid when it comes in contact with a cold surface?
Condenses.
Yeah, okay, so in this case, you know, we don't really think of that being a cold surface, but it's cooler than the rest of the area, and it is cool enough that it will have some moisture, some fuel condense around those surfaces. And of course, when it condenses, it's back in liquid form and it won't burn.
Right, right.
So now it goes out the tailpipe as raw fuel. So yeah, quenching's bad.
Okay.
And they do a lot of things to try to keep turbulence going so that it doesn't have enough time against the cold surface to condense.
See, that's some of the stuff that confuses me, because now we're talking about cool air being good as it comes in,
Cold air is good, yes.
but then it cooling the sides is not good.
The air-fuel mixture, when it's vaporized coming in contact, allows some of that fuel to condense on those surfaces, so it turns back to liquid. So that's bad. There are a lot of things that are trade-offs,
Right.
right? And so, you know, but, you know, keep in mind, other than on cold start, we're not controlling the temperature of the air coming in. Yeah, on turbocharged engines with intercoolers we are, but we're pressurizing it, which brings the heat way up, and then run through the intercooler to bring the temperature back down before it goes into the cylinder. So as far as the temperature of the air going into the cylinder on a turbo vehicle that has an intercooler, to be honest with you, I don't know if it's cooler or the same or warmer than the outside air temperature. But I do understand that when it goes through that compressor, it's heating up, and then the intercooler cools it back down some. But I'm not sure to what temperature-wise. I'm sure that varies. I mean, you know, at lower RPM, it's probably doing a really good job of that. At higher RPM, it's probably not. You know, but it's, you know, better than not having the intercooler. You know, inside of our cylinder, of course, our temperature is controlled somewhat by how well we're getting cool air in, as well as how well we're getting the hot stuff out, hot exhaust out, you know, you know, and compression ratio affects that. So a lot of things affect that, and valve timing affects that because that affects pressure in the cylinder too. And so, yeah, we can have lots of things affecting that. Okay, so we've talked about PCV valves a little bit. This is a pretty good diagram here of how the system is set up on most vehicles, especially on carbureted vehicles like we've got drawn here. Basically, that vacuum hose over here that's hooked to the PCV valve is sticking into the intake manifold somewhere. So it's got an intake manifold vacuum on it. Now, if you remember when we were doing the vacuum test on that Saturn, we pulled that brake booster hose off. You know, that was about a 3/8 diameter hose, which typically most of our PCV valve hoses are about that same size. They're big, pretty big hose. There's a lot of vacuum there. If you put your thumb over it with it running, I mean, it's enough that, you know, if you hold your thumb over it with it running for a while, it starts putting this little blood blister, or whatever, not really, a hickey on your thumb,
Yeah.
right? And so there's a lot of vacuum there, okay? Well, the PCV valve itself has a little plunger and spring in it to help control that or meter how much actually flows, so that it's not just straight vacuum to it. Because if we had straight vacuum there, then we'd have problems. You know, it would pull seals in, and I mean, you know, it could do some crazy things. The other hose, on the other hand, over that, it's where the fresh air goes into the crankcase, and that's going to be hooked up to the air intake somewhere, normally filtered. So in other words, behind or between the air filter and whatever type of fuel system we have. On the carbureted vehicles, you know, they were all pretty much up to the side of the air cleaner. And it had its own filter. It didn't actually use air that was going through the regular air filter on this style. It had its own little filter that stuck in a little plastic holder in the side of the filter housing. And one sign of an engine that has too much blow-by that the PCV valve cannot handle is that filter up there starts getting oily. And so what's happening is actually enough pressure in the crankcase that some of it's going back the other way. And so there'll be this small amount of oil. Well, it can be a large amount over time. When you get one that's really, really warm, it can be, you know, pretty obvious. You know, you pull the lid off the air cleaner and there's oil all in the bottom, you know, a layer of oil. So just depends on how warm the rings are, how much they're leaking. You know, we have to have a certain amount of blow-by because we can't have our rings too tight or they just score the cylinder walls. The engine can fail. Our crankshaft is designed to either with the counterweights of the crankshaft throw oil up on the cylinder walls to help oil them, or some of our connecting rods have a little spurt hole in there.
Yeah, I saw that when we took it apart there.
Right. Yeah, that one you'll have a part had a spurt hole. So as it comes around, it's spraying oil up on the side of the cylinder walls. And so that's designed, you know, of course, to lubricate the cylinder walls. There are some engines, by the way, that have a, what they call a jet valve. And a jet valve is a little, for lack of a better term, it's a little poppet nozzle with a little hooked piece of tubing that's pointed up at the bottom of the piston to help cool the head of the piston from the bottom. It sprays oil directly up in the bottom of the piston. And not many manufacturers do that, but quite a few do. And it's probably more prevalent with imports. But that's kind of an off different subject where we're at here, but there again, you know, our first attempts at controlling emissions was PCV valves. Got rid of that piece of pipe that was just sticking outside the bottom point of the ground, and so that helped clean that up a bunch, right? So you'll see, like on this situation here, you know, this is a throttle body or TBI, or, well, it's got a throttle body there, so it would have to be a port rejected vehicle. And so you can see where the PCV valve is, and that hose is actually running in behind the throttle plate, okay? Or downstream of the throttle plate, I guess you should say, on the intake vacuum side of the throttle plate. And then the fresh air is over here just in the snorkel. So in this case, that air would be filtered by the regular air filter. But they're always got either filtered by the regular air filter or have their own little filter on them, depending on the type. Okay. Okay, so here's a PCV valve. Notice it says at the top, engine not running, and this is not a great drawing, but you know, these little dots right here, this is a spring, okay? So you use your imagination because they didn't draw the spring all the way around it, but there's a spring there, okay? So you have this, notice that's tapered where that goes up into the port up there, and then there's a couple of steps. So each one of these is going to be specific to the engine, okay? So that it's controlling how much controlled vacuum leak we have there, right? And so when the engine's off, of course, that spring is going to close that valve. When we start the engine, we have vacuum at the top and, of course, some pressure at the bottom. So the spring is kind of calibrated, and the shape of that panel and angles and all that calibrated. So as the crankcase pressure builds a little bit, it allows that to unseat, okay? But it'll work back and forth pretty much constantly. And so the test procedure is pull it out, take it in your hand, and shake it. And the little weight, you know, the little, I say weight, it's a pendulum really, but you'll feel it going back and forth. You'll be able to hear it. You know, it's one procedure. Another test procedure is with it running, pull it out of the cylinder head or valve cover and stick your thumb over the end of it. When you do, you stop the vacuum flow, right? The spring will push it down. See, it'll click, and then you move your thumb and it'll click the other way. And you can sit there and just go back and forth with your thumb and hear it clicking.
So is it heavy enough to shake it for it to move like
Yes.
that? Oh, wow.
Yes. Yeah, that piece in the center is steel, and you know it's not real heavy, but it doesn't have to be heavy. It just has to be enough weight with spring tension to be calibrated for however much pressure is against it from blow by. Okay. Now, all throughout our lifetime, they tell us. It used to have like a 15,000 mile service interval on them, you know, back when spark plugs were over 30,000 miles and that sort of thing. And most people didn't, and we'd always try to do it when we did the spark plugs at 30,000 miles. But to be honest with you, they very seldom actually fail. What happens is they get carbon and stuff built up in them. You know, you've got all that blow-by stuff that's got oil and fuel in it, and it'll leave a residue in it. You can clean these out with carburetor cleaner real easily. You know, just pop them off and hose them out, rattle them a little bit, hose them some more, blow them out there, and put them back on. You know, of course they're not expensive, but still, it's like very seldom do they get to the point where they're out of calibration because the spring gets weak, but that does happen. Okay. The other thing that happens more though is when they get some corrosion, carbon buildup in there, and don't fully close, because it ends up down here at the bottom too. It doesn't fully close, and now it's leaking too much, pulling too much vacuum in it, and it does can create link mist and stuff because it's lean. It's too lean. It's a vacuum leak. You know, when it's working properly, it's a controlled vacuum leak. When it's not working properly, it's either stopped up, not doing anything at all, or it's too much of a vacuum leak, and it will affect the fuel mixture. And so, on pre-computer-controlled cars, it was pretty obvious when that happened. Okay, because the computer was not adjusting. It didn't have a computer in those to adjust fuel mixture to try to cover up for the lean condition. On computer-controlled carburetors and injection stuff, the computer will cover that up until it gets really bad. You know, you probably won't notice anything. Okay. Idle or deceleration. Now, you'll see that, notice it says PCV valve is closed. Let me back up here. PCV valve is closed. Okay, it has two closed positions, right? Closed that way or closed all the way this way. So it can seal off at the bottom or seal off on the taper at the top. So it depends on what the position is at, right? On idle or deceleration, our intake vacuum is higher than any other time, right? Deceleration is when it's the highest vacuum level, okay? So at that point, that's going to pull that up, okay? Driving down the road, just cruising, this will be somewhere in the middle, okay? Quite often it moves just back and forth from closing off, opening up, closing off, opening up, you know. The amount of blow-by and pressure in the crankcase is going to affect that also, right? Now the other thing that gets into effect on these is the fact that when we have a lot of blow-by around the rings, we also have less vacuum in the engine, okay? Because the vacuum is created when the piston's moving down and our rings are sealing against the cylinder wall, okay? If they're not sealing well, less vacuum will be created. And then, of course, under compression and all that is when the stuff blows around the rings. Okay, so the condition of the engine is going to affect it a little bit. Acceleration or high load. You know, first thing we think is our vacuum goes away, that spring should close that, right? But the pressure from the crankcase is going to push it open in that case, because under acceleration or high load, we have more blow-by around the rings. Okay, so it's a simple system that works really well, you know, and they haven't changed that since they designed it. There have been virtually no changes in the PCV system since whenever they started in the late 50s, early 60s. It's really one of the few things in our little world that really hadn't changed. You know, even, I mean, I can't think of really anything else, maybe heater cores, other than they went from copper to aluminum. That's the only other thing I can think of on a car that really hasn't changed since it's been there, you know what I mean? So it's kind of interesting in the fact that that's the case. I don't have a clue who invented it, but I'm sure they're dead now, but they hope they got rich. Yeah. You know, because every manufacturer does it the same way. Now there are some differences in locations on the valve, and there are some situations where, like Jeeps, a lot of the Jeeps do not use a regular PCV valve. They use a metered orifice, which basically is a small piece of pipe, and it controls how much is pulled through the vacuum. It doesn't work as well as one of these, okay? But other than getting stopped up, you know, you don't have a spring to fail, right? It's part of the valve cover, okay? So when it does fail and you can't get it cleaned out, because that's really the only way they fail is when they get stopped up. They get stopped up with carbon. If that carbon's hard enough that you can't wash it out with carb cleaner or whatever, you replace the valve cover. Okay? So a lot more expensive repair than just buying a PCV valve. Of course, testing things, make sure the hoses are in good shape, and check the PCV valve part number against the application, because this is another one of those things that they all pretty much are the same size externally, and people put the wrong ones in, and I've run into that a few times where it was a lean condition and it had the wrong PCV valve in it. Now, the worst part of that is you as a technician, when you get to that point, pulling a PCV valve, looking at the part number, doesn't tell you anything, because you don't know what's supposed to be in that car. So then you're going to have to try to look at the application. You'll have to look it up and see what part number is supposed to be in it. Okay. And so you'll run into that from time to time, because sometimes people in independent shops a lot, they'll keep, you know, if for some reason they've got an extra PCV valve out of something or whatever, they'll throw it in a box or whatever. You know, it's not like they're expensive, but anyway, they'll sometimes grab, here I got one, let's put that in there and send it down the road, you know. Maybe the wrong one. If you're blowing air through this, okay, remember that it's spring loaded, okay, but from the vacuum side down, you're blowing with the spring, you're blowing against that taper, and it's blowing into the seat, so it should not blow through that way. If you're blowing the other way, it will blow until you blow too hard, and it'll move it up the seat the other way. So, if you're going to blow through one to see if it flows, I suggest just blowing with your mouth instead of using an air nozzle, but most of the time, air nozzles don't shove it shut. You know, so it's one of those deals. You know, they're demonstrating here that the your finger over it, I guess, just to click, right? PCV systems recirculate crankcase vapors to where?
Into the manifold, isn't it?
Right, into the intake manifold. Yep. That way they're burning it instead of dumping it out in the atmosphere. Okay, ignition control systems. So we talked some a couple weeks ago, I guess, about ignition systems, and we'll do more when we go out in the shop for sure. One of the things that's pretty critical on the performance of our engine is when we ignite our spark, right? When we ignite our fuel with our spark, I should say. And so timing is very important. Remember that we are trying to get the maximum pressure in our cylinder from the burn of the fuel when our crankshaft is somewhere around 10 to 15 degrees past top dead center. That's where we get the most torque out of it. Okay. And so the faster we spin the engine, the faster we have to advance the timing to get that same burn done. Because regardless of how fast we're spinning the engine, it still takes up to about 3 milliseconds to burn that fuel. Okay. So 3 milliseconds at 1,000 RPM means we have to have our timing X number of degrees before top dead center. 3 milliseconds at 4,000 RPM means we've got to have it quite a bit more before top dead center to still get that power in that location within that same time frame. So that's the job of our ignition control system, or timing control system on our engines. Now, if we advance our ignition timing too much, it increases hydrocarbons and NOx emissions. It also increases the chance of pre-ignition on our fuel. Okay? And it's really a pre-ignition situation that we're causing by advancing the timing too much. And so when we have the pressure forces in the cylinder hitting the top of the piston before the piston gets to top dead center, it's basically trying to force the crank backwards. Okay? But the momentum of the crank, the flywheel, and the other cylinders producing power keep that spinning around, right? But it's getting that explosive force on top of it, and it makes a knock noise. Okay? What we call ping or spark knock. Okay? Well, this is a knock sensor right here. Okay? And so this sensor will be threaded into a coolant passage, almost always into a coolant passage. I'm not sure that I've ever seen one that was not. Okay? The reason it's threaded into a coolant passage is because that coolant will help transfer that vibration or noise throughout the engine. Okay? So we can run a knock sensor over in the side of the block. You know, GM for years, their knock sensor was in that side of the block where they normally have a plug on one side and a knock sensor on the other side, or before we had knock sensors, had plugs on each side. At the bottom of, right just above where the oil pan bolts, the bottom of the block. I can pretty much say, I think 100% of the time, it's on the side where the starter's at, on the passenger side of the block. And so it's, you know, it's right in front of the starter, so people damage these or the connector when they're changing starters, okay? Because it's like this far in front of the starter, and when they go pull it out, they hit that. This portion of it right here is plastic, okay? And so you can crack right there. So when you're changing starters, be careful of that. Just go in there and unplug that first, so you're not fighting with the wire when you're trying to get the starter out of there. But so this is piezoelectric crystal. It's going to produce a voltage when it senses a vibration. Okay. Most of these have a reference voltage to them, but that reference voltage is just there to check the continuity of the circuit. It's a one-wire sensor. Okay. And so you will find that if you unplug that wire with the key on and stick a voltmeter on it, oddly enough, at least on the GMs, they run 8 volts to it. It's different than about everything else GM did. It was either 12 volts or 5 volts, but this one is 8. Okay. Now here's what's kind of crazy about it. That's an 8 volt DC signal. Okay. And the computer is using that to monitor to make sure it's plugged in. There's continuity. Okay. This piezoelectric crystal produces an AC signal when it sees a vibration or senses a vibration.
So it converts it from AC to DC?
It does not convert it. The AC signal rides on top of the 8 volt DC signal back to the module.
Yeah, that's weird.
It is weird. It is weird. And when they first started doing this, it just kind of blew my mind. It's like, how can you have AC and DC on the same circuit, you know? And it just doesn't make sense, but it happens, okay? They are at different voltage levels, so the computer can see the difference. Okay? And I don't remember now what the voltage level is on those, but the computer, and I say computer because we had these before we had computers in our cars, okay? And at that point we had what was called a knock sensor module. And the knock sensor module didn't have a processor in it, but it basically had the means of seeing that AC signal. And when that AC signal amplitude was high enough to switch a transistor, it switched a transistor. When the transistor switched, that was tied in with the ignition module spark timing. And it would, every time that transistor switched, it slowed the timing down 2 degrees. Okay? And they could go all the way to 20 degrees. And so if you had an engine that had a heavy spark knob or ping or whatever you want to call it, like you were going up a big hill, because that's when under loads when that usually happens the most, and it starts pinging, that module starts dropping timing back 2 degrees at a time. And so, like I say, just pretty much all of them could go 20 degrees. When we got into computer controlled ignition systems, they still have this, they still have the knock sensor module. Matter of fact, a lot of our earlier computers, and I say earlier, up until 95, I think, on the GMs, the knock sensor module was part of the computer. In 95, the knock sensor module actually was a plug-in chip, big square chip, that plugged into the side of the computer. They had already done away with PROMs that were a plug-in chip and gone to electronically erasable PROMs. And so then the next thing you know, you got knock sensor modules plugged in there. Okay? You got to remember when you're swapping computers to swap that knock sensor module to the new computer, because it don't come with a new one in it. So there's been, you know, some changes throughout the years. On GM, on their 5.3s, when they came out with the active fuel management engine, the one that drops cylinders, they moved those, and they actually have 2 knock sensors. They moved it up. There's the oil control plate that mounts typically where our old aluminum bottom half of our intake manifold mounted, in between the cylinder heads. Actually, this is lower because it's not actually mounted to the cylinder heads. The heads will come off, and this plate's mounted to the block. This oil control plate is what controls the oil pressure to the lifters to engage and disengage them for the cylinder control. There also is coolant passage through that, and there's 2 knock sensors mounted in that. Okay. Well, the problem with that is when one of them fails, they are connected together parallel. So when one of them fails, it affects the other one too. And you don't have a clue which one's bad until you rip it apart. But everybody replaces both of them, okay? And they had some problems with the harnesses, because there's a little pigtail harness that plugs into those two, and it comes out from under the manifold and has a plug-in for the main harness. And they had some problems in that harness. So if you run into one of those, you know, and there's bulletins on it, replace both knock sensors and the little pigtail harness. Because anytime you have a failure with that, you know, because you got to pull the intake stuff off to get to it. And so that's the fix. And I think now if you go to the parts counter to dealership, they're not going to have those separate. It's going to come in a kit with two knock sensors and a harness, you know, because that's the fix. But anyway, so the knock sensors, we've had them for a long time, and they pick up that vibration. Well, if we have a loose rocker arm or a failed active fuel lifter and that rocker arm's ticking, if it's ticking loud enough, the knock sensors will pick that up too and slow the timing down. So now you have a situation of one cylinder that's not producing as much power because now the lifter's not opening all the way because of the active, well, if it's an active fuel, failed active fuel lifter, that cylinder's not firing at all. Okay, it's not opening the valve. And the knock sensor slowed the timing down 20 degrees. So now the rest of the cylinders that are firing too late. And so it really hurts the power on that situation. I've had some of these 5.3s that had lifter failures because they went through a batch of that and had more than one dead cylinder. And the timing slowed all the way down, and they just barely can limp them in the shop. You know, they don't want to run. And so that's a kind of a common thing. I think they're not very common anymore, but it was, say, 6-8 years ago. Andy left, but I wanted him to see this. So testing the knock sensors, quick and easy thing. You can hook your scan tool up, look at the knock retard or knock sensor signal. It depends on the vehicle, what it's going to show. And I don't like to use a hammer that big, but you can walk out there and, you know, run your scan tool out the window and around the front there where you can watch it while you tap on the exhaust manifold. Okay. You know, be careful you're not hammering on plug wires and hammering on oxygen sensors and such, but you can sit there and tap on it and see the knock sensor counter start counting up. If you take your timing light, if it's a vehicle that's got timing marks, you can take the timing light over there and point at the timing marker and reach there and tap it and watch it slow the timing down. And so that's kind of cool, you know.
Yeah.
It's a quick and easy thing. You know, it says tap near the sensor with a hammer, but you know, most of those sensors are down low or buried under the plastic intake, so don't be tapping on the plastic intake. Exhaust manifolds usually work pretty well. So anyway, you know, they're quick and easy to test that way. You know, as long as you've got a scan tool or a timing light hooked up. All right, let's take a break.
Run down and get a coffee, I think, real quick.